Hello everyone. Welcome back to Sally and Bytes. Imagine a world without the internet. No Google, no YouTube, no online gaming. Hard to believe, right? But networks weren't always as advanced as they are today. Let's take a journey through time to see how we got here. What if I told you that the internet, the very thing that lets you watch YouTube, chat with friends, and even order food, was born because of a tiny beep from space? Yes. This single beep changed history and set the stage for the world of networks. Today, we'll explore the evolution of networks, from ARPANET to NSFNET, the internet, and beyond into interspace. It all started in 1957, when the Soviet Union shocked the world by launching Sputnik 1, the first ever artificial satellite. It was a simple metal sphere with 4 antennas, and all it did was send a beep, beep, beep signal back to Earth. But why did this matter? This tiny beeping satellite triggered the space race between the US and the Soviet Union. The space race, 1957 to 1975, was a Cold War competition between the USA and USSR to achieve major milestones in space exploration. It played a crucial role in advancing satellite technology, networking, and the birth of the internet. Feeling the pressure to keep up, President Dwight D. Eisenhower created DARPA, Defense Advanced Research Projects Agency, also called ARPA, in 1958, which later became the foundation for the internet. However, the U.S. efforts to quickly catch up with the Soviets in the space race led to the creation of NASA. With NASA's establishment, ARPA's space and rocket projects were transferred to the new agency. This shift prompted ARPA to seek innovations in new areas and sectors. Two key groups, the U.S. military and the academics, were interested in networking. U.S. military. During the 1960s, the Cold War created a lot of tension between countries, especially between the U.S. and the Soviet Union. The U.S. military relied on telephone networks for communication, but these networks had a major weakness. They used direct connections, circuit switching. This meant that if a nuclear attack or any damage destroyed one part of the system, the entire network could stop working. For example, imagine an old landline telephone system where 2 phones are directly connected through a wire. If the wire is cut, the call is lost. The military feared that in a nuclear attack, multiple wires could be destroyed, making it impossible to coordinate responses, which could be a disaster in an emergency. Academics. Meanwhile, universities had a different challenge. In the 1960s, mainframes were large, powerful, and expensive computers used by universities, businesses, and government institutions. And here's the problem: every time someone needed to use a different computer, they had to physically move to that location. Imagine if you had to change seats every time you wanted to visit a new website. Annoying, right? Instead of waiting for their turn to use a computer, scientists wanted a way to share its power. DARPA's mission was to create a network that connected these massive computers, so researchers could share data and programs remotely. Now, let's meet the Internet's founding fathers. J.C.R. Licklider, a computer scientist and psychologist, led ARPA to focus on computer science and imagined a world where computers were connected, calling it an intergalactic computer network, similar to today's Internet. At that time, mainframe computers were isolated, could do only one task at a time, and often sat idle. He introduced time sharing, allowing multiple users to share a mainframe simultaneously, making them more efficient. Since mainframes were huge and expensive, most research centers could afford only one, limiting complex tasks. Licklider wanted a network to connect computers and share resources remotely. Though he left ARPA in 1964, his vision laid the foundation for the Internet. 2 years later, another scientist, Robert William Taylor, also called Bob Taylor, took Licklider's vision and turned it into a real project. In his office, he had 3 computers, each connected to a different system, but these systems couldn't communicate or share data with one another. This gave him an idea: what if all computers could connect and share information? This idea led to the creation of ARPANET, which later grew into the Internet we use today. Paul Baran was a researcher in the 1960s who worked for Rand Corporation in the USA. He came up with a new way for computers to send data, called packet switching. Instead of sending data in one big piece, it was broken into small packets. These packets traveled separately across the network and were put back together at the destination. His idea was important for the U.S. military during the Cold War because it made communication networks stronger. Even if some parts of the network were destroyed, the messages could still reach their destination. This idea later became the foundation of the Internet. Donald Davies was a British scientist who worked at the National Physical Laboratory, NPL, in the 1960s. Around the same time as Paul Baran, he also came up with the idea of packet switching, a method where data is broken into small packets and sent across a network. He was the one who named these data pieces packets, a term that became essential in digital communication. His work helped shape ARPANET, the early Internet in the USA, and later influenced how the Internet developed in the UK. Leonard Kleinrock was an American professor who worked at MIT and later at UCLA in the 1960s. In 1961, during his PhD, he developed the mathematical theory of packet switching, showing that this method could efficiently manage data traffic in networks. His research helped prove that packet-switched networks were a better way to send data compared to older methods. In 1969, his team at UCLA sent the first ever message over ARPANET, the earliest version of the Internet. This was a major milestone in the history of digital communication. Lawrence Roberts led the ARPANET project and oversaw its implementation. Licklider imagined the network, but these pioneers built the technical foundation with packet switching. Their work directly led to ARPANET. One big problem in early networking was that different computers were built differently and couldn't easily communicate with each other. To connect them, scientists developed two key technologies. Interface Message Processor, IMP. This was a special hardware device that worked like a translator. It helped different types of computers understand each other and acted as the first router, directing data between them. Network Control Program, NCP. This was an early set of rules, protocols, that managed communication between computers, ensuring they could exchange data properly. The first 4 locations connected by ARPANET were University of California, Los Angeles, UCLA, the first node, where the first ARPANET message was sent. Stanford Research Institute, SRI, home of the Network Information Center. University of California, Santa Barbara, UCSB, focused on mathematical and computing applications. University of Utah worked on graphics and visualization research. With these 4 nodes, the world's first large-scale computer network was born. On October 29, 1969, the first message was sent over ARPANET. Leonard Kleinrock led the project and played a key role in developing packet switching theory, a foundation of modern networking. This historic moment took place between 2 computers. Sigma 7 at UCLA. SDS 940 at SRI. These computers were connected via an IMP, Interface Message Processor, a precursor to modern routers. In 1969, teletype terminals like this one were essential computing devices. The first message was the word, login. Charlie Klein, a UCLA student programmer, typed the letter L and sent it to Bill Duvall, a programmer at SRI. Bill received the letter L. Klein then typed O, which was successfully transmitted. However, when he typed G, the system crashed and the full word login couldn't be sent. Thus, the very first message in Internet history was simply "Low." About an hour later, the system was fixed, and the full word login was successfully transmitted. This event proved that computers could communicate over a network, laying the foundation for the Internet. By 1972, ARPANET had grown to 15 nodes, and scientists started developing new applications. Email, electronic mail, became one of the first and most significant uses of networked computers. It allowed people to send electronic messages instantly, transforming communication forever. In 1971, Ray Tomlinson, an American computer engineer, developed the first email system on ARPANET. He also introduced the use of that symbol to separate the user's name from the computer or domain they were using. An essential feature still used in email addresses today. Why was email important? It was faster than traditional mail, hence electronic mail. It enabled instant communication between researchers, businesses, and later, the public. It paved the way for modern messaging, including chat, social media, and work collaboration tools. By the 1990s, email became a standard part of daily life, thanks to web-based email services like Hotmail, Yahoo Mail, and Gmail. Today, email remains a cornerstone of digital communication, widely used for personal, academic, and professional interactions. But ARPANET was still limited to research institutions. A bigger network was needed. The problem with ARPANET is that it used an outdated protocol called NCP, Network Control Protocol, which couldn't connect different types of networks. That's when Robert Kahn and Vint Cerf introduced TCP/IP, Transmission Control Protocol and Internet Protocol, in 1978. Think of TCP/IP as the language that computers use to talk to each other over the Internet. It works in two parts. TCP, Transmission Control Protocol, like a delivery service, it breaks data into small packets, sends them across networks, and ensures they arrive correctly. IP, Internet Protocol, like an address system, it guides these packets to the correct destination, just like a GPS directs you to a specific house. This breakthrough allowed computers across different networks to communicate seamlessly, making it possible for different systems to talk in a common language. And here's the best part, it's the same protocol that powers the Internet today. On January 1, 1983, ARPANET officially switched to TCP/IP, marking the birth of the modern Internet we use every day. With ARPANET laying the foundation for network communication, the next major leap came with NSFNET, National Science Foundation Network, in 1986. The NSF wanted to expand network access beyond military and research institutions, making high-speed networking available to universities and researchers across the U.S. It replaced ARPANET as the backbone of the Internet, offering higher speeds, 56 kilobits per second, later upgraded to 1.5 megabits per second and beyond. It connected universities and research centers nationwide, allowing greater collaboration. Most importantly, it paved the way for the public Internet, as private companies and commercial users were eventually allowed access. By the early 1990s, the World Wide Web, WWW, emerged, and NSFNET transitioned into the modern, commercial Internet we know today. This shift made the Internet accessible to businesses, schools, and individuals, marking the start of the public Internet revolution. By 1990, ARPANET was officially retired, but its legacy lived on as the Internet exploded worldwide. While networks were expanding, there was no easy way for people to find and share information across different systems. In 1989, British scientist Tim Berners-Lee introduced the World Wide Web, WWW, a system of interlinked documents that could be accessed through the Internet. This breakthrough introduced three key technologies. HTML, Hypertext Markup Language, the language used to create web pages. HTTP, Hypertext Transfer Protocol, the set of rules for transferring web data. URL, Uniform Resource Locator, the web address system to find pages easily. The first website went live in 1991, hosted at CERN, European Organization for Nuclear Research. By the mid-90s, the Internet was open to the public, leading to the dot-com boom, a rapid expansion of websites, businesses, and online services. The commercialization of the Internet led to an explosion of websites. Companies like Amazon, 1994, eBay, 1995, and Google, 1998, emerged. Many tech startups flourished, but the dot-com crash, 2000, wiped out overhyped businesses. The dot-com crash, also known as the dot-com bubble or the Internet bubble, was a period between 1995 and 2000 when investors invested their money in internet-based dot-com companies hoping to make profits that did not happen. The rise of social media, 2000s. Platforms like Friendster, 2002. One of the earliest social networking sites. MySpace, 2003. A hugely popular platform before Facebook took over. LinkedIn, 2003. A professional networking platform. Facebook, 2004. Started for college students and later expanded globally. YouTube, 2005. Revolutionized video sharing. Twitter, 2006. Introduced the concept of microblogging. These platforms changed how people interacted. The internet became a space for social connection, content sharing, and real-time communication. The mobile internet and apps. Smartphones and 4G networks transformed the internet into a mobile-first experience, meaning that most users accessed it through their phones rather than desktops. Rise of social media and apps. Instagram, 2010, Snapchat, 2011, and TikTok, 2016, reshaped digital culture with visual content and short videos, while Facebook, Twitter, and LinkedIn evolved for marketing and branding. Cloud computing boom. Services like Google Drive, Dropbox, and iCloud simplified data storage, while AWS, Azure, and Google Cloud powered business scalability. AI and automation. Assistants such as Siri, Alexa, and Google Assistant became popular, while machine learning improved recommendations on platforms like Netflix, YouTube, and Spotify. Internet of Things, IoT. Smart home devices like Amazon Echo and Google Nest, wearables such as Fitbit and Apple Watch, and connected cars contributed to the expansion of IoT adoption. E-commerce and digital payment. Platforms like Amazon, Alibaba, and Shopify fueled online shopping, while PayPal, Apple Pay, Google Pay, and UPI enabled seamless transactions. Streaming revolution, Netflix, YouTube, Hulu, and Disney Plus changed the way people watch TV, making cable TV less popular. Similarly, Spotify and Apple Music changed how people listen to music, replacing CDs and downloads with streaming. On-demand economy. Uber and Lyft changed the way people travel by making it easy to book rides using a phone app. Similarly, DoorDash and Zomato changed food delivery by allowing people to order meals from restaurants and have them delivered to their homes. Gaming and esports growth. Mobile games like PUBG Mobile, Fortnite, and Clash of Clans became very popular, and esports grew into a billion-dollar industry where players compete in video games for big prizes. The 2010s prepared the world for 5G, which helped smart cities, AI, and new digital experiences grow faster in the 2020s. The age of AI and 5G. Faster connectivity enabled smart cities, autonomous vehicles, and IoT. AI tools like ChatGPT, Alexa, and Google Assistant enhanced digital interactions. Metaverse and virtual reality, augmented reality. Companies like Meta, Apple, and Microsoft invested in immersive virtual worlds, AR glasses, and digital twins for business simulations. Blockchain and Web3. Cryptocurrencies, NFTs, and DeFi transformed finance, while smart contracts and DAOs reshaped governance. Quantum computing. Google, IBM, and Microsoft have made big advancements in quantum computing, and quantum cryptography is improving data security by making it nearly impossible to hack. AI-driven climate models. Scientists use artificial intelligence, AI, to predict climate changes more accurately. AI analyzes massive amounts of data, like weather patterns and carbon emissions, to forecast future climate conditions. This helps us prepare for extreme weather and plan better ways to reduce pollution. Optimized renewable energy. AI also helps make renewable energy, like solar and wind power, more efficient. It predicts when the sun will shine or the wind will blow, so energy production can be planned better. The rise of EVs, electric vehicles. More people are using electric cars instead of gasoline-powered ones. EVs produce less pollution, and as battery technology improves, they can travel longer distances. Plus, AI helps optimize charging stations, making EVs more convenient and accessible. Biotechnology and AI are working together to improve medicine. CRISPR gene editing, a special tool that can change DNA, helping to fix genetic diseases. AI-assisted vaccine development. AI helps scientists create vaccines faster by studying viruses and predicting the best way to fight them. Brain-computer interfaces, devices that connect the brain to computers, helping people with disabilities control machines using their thoughts. Space travel and technology are growing fast. Space tourism. Companies like SpaceX and Blue Origin are making it possible for regular people, not just astronauts, to visit space. Mars missions. NASA and SpaceX are working on sending humans to Mars for exploration and future colonization. Global satellite internet. Satellites launched by these companies are providing high-speed internet to remote areas around the world. Interspace is the next step in digital evolution, and also the next level of the internet. While the internet helps us search for information and communicate, interspace takes it further by making information more interactive and 3D. Imagine walking through a virtual world where you can explore knowledge visually instead of just reading text on a web page. For example, instead of searching for solar system and reading articles, you could enter a 3D space where planets move around you, and you can interact with them, zoom in, rotate, or even hear explanations. It combines multimedia, virtual reality, and advanced computing to create an immersive experience for learning and working with data. Multiple users can interact in the same digital environment, making it great for virtual education, research, and teamwork. An interface is software that enables multiple users in a client-server setup to exchange data like files, audio, and text in a 3D environment. It supports real-time online data sharing. Interspace is one of the most advanced internet communication technologies today. From ARPANET's first message to today's AI-powered internet, networks have come a long way. Who knows? The next evolution might be even bigger. Thanks for watching. Don't forget to like, share, and subscribe for more tech stories.